Hey, welcome back. So in our previous video, we talked about a Taylor polynomial. So in this case right here, we are going to just do some of our homework together. So in the first example, we want to find a Maclaurin polynomial of degree n. So Maclaurin, remember, is a Taylor with the center c equal to 0. So anytime you see Maclaurin, we're saying we're just centered equal to 0. Before we begin, I'm going to go ahead and write out my Taylor polynomial rule. Whoops, should be of x. Yep. My nth degree Taylor polynomial is the following. We said it is the value of the nth derivative at the center over n factorial times x minus our center to the n. There it is. The most important formula for the rest of the year. So when we look at n, remember n is the nth degree, but for us, it really means the number of derivatives that we need in them for the most part. There are some special circumstances, but we'll talk about that later on. Now, so if we take a look at the first one, e to the 3x, and where n is 4. So what this is telling us is that we need 4 derivatives right here. So so starting, I'm going to start with the value of the original function. That's f0. That's the 0th derivative. It's the first function, the original function. So we e to the 3x. Our first derivative, using chain rule, we would get 3e to the 3x. Our second derivative, chain rule again, we wind up with 9e to the 3x. The value of the third derivative would be 27e to the 3x, again, chain rule. And the fourth derivative would give us 81e to the 3x. So there's our 4 derivatives. Next, now we want to find the value of the nth derivative. So now we're going to generate the coefficients. That's the hard part. The value of our nth derivative at c, at that center. So that's going to give us the value of the 0 derivative at 0. We're going to get e to the 0, which is 1. The value of the first derivative at 0, we're going to get 3e to the 0, and that's going to become 3. The value of our second derivative at 0, we're going to get 9e to the 0, and that's going to give us 9. The value of our third derivative, that's going to become 27e to the 0, which is 27. And then the value of our fourth derivative would be 81e to the 0, which is just 81. So now we're going to generate our polynomial. That's the most amount of work you have to do ever in your life. So now we're going to generate our polynomial. To do that, we would say p sub 4 of x is. We're going to say this is equal. Okay, now there's another we can write, and we'll talk about that in a minute. So my rule says take the top of the coefficient that we just found, which in this case was a 1. So that's going to give us 1 over n factorial, which is 1. Uh, and that's going to become x minus 0. So remember, we're doing n equals 0 first, right? X minus 0 to the 0 plus, remember, we're going to add these. Now we're going to let n equal 1. Plug in this, we get 3 over 1 factorial, x minus 0 to the 1. Let n be 2. Same thing. When n was 2, we got 9 over 2 factorial, x minus the center, 0 squared. Plus, let n equal 3. And we get 27 over 3 factorial, x minus 0 cubed. And if we let n be 4, we're going to get 81 over 4 factorial, x minus 0 to the 4th. Now, you can leave it like this. This is perfectly okay to leave. Nothing wrong with that. We will accept that. That is fine. But if you clean it up, the entire first term is just 1, plus this becomes 3x plus 9 over 2 factorial x squared plus 27 over 3 factorial x cubed plus 81 over 4 factorial x to the fourth. And we would write this as our fourth degree Taylor polynomial. Now, like I said, there's another way we could write it. We could also say e to the 3x approximates all of that. And there we have, there it is. That's very easy. So go and try the next two, 2 and 3. But I want to take a look at number 4. Let's not do number 4. Let's take a look at number 5. Oh no, we have a trig function here. And so for number 6, I'm sorry, we have a trig function right there. And for this one, we want n equals 3. So again, what they're saying, they want 3 derivatives for now. So I'm going to go and do that. My original is sine of x. My first derivative, cosine of x. My second derivative, negative sine of x. Now, but notice our center is at pi over 6. This one is not Maclaurin. This is a true Taylor. So now I want to find the value of the function at pi over 6. And that's just the sine of pi over 6. Uh-oh, that's going to be embarrassing, which is just, whoops, hello, 1/2. Next, I want to find the value of the cosine of pi over 6. Well, that's just root 3 over 2. The value of the second derivative at pi over 6, we're going to get negative 1/2. And all we have to do now is plug this into our Taylor. There's our Taylor polynomial. The value of the nth derivative at the center divided by n factorial, x minus the center to the n. So this is a third degree Taylor. So we're going to write a p sub 3 of x is, ready? The first one, the value of this becomes x 1/2 over 0 factorial x minus pi over 6 to the 0 plus root 3 over 2 over 1 factorial x minus pi over 6 to the first, and then the last one minus 1 over 2 over 2 factorial x minus pi over 6 squared. Now, we don't like this. This looks terrible. A couple things. Remember, 0 factorial is just 1. I did make a mistake up here for question number, for this example up here. I do want to go back and fix it. This should be a 0 factorial, but 0 factorial is just 1, so it doesn't really affect our answer in the end. So over here, when we would reduce it, p sub 3 of x, this just becomes 1/2 x minus, well, this just becomes 1 because it's to the 0 power. So I go plus. When I take a look at root 3 over 2 over 1 factorial, I can just write that root 3 over 2 times 1 factorial x minus pi over 6. Minus, same thing over here. This becomes 1 over 2 factorial. And that's going to give us 1 over 2 times 2 factorial x minus pi over 6 squared. And there would be our third degree Taylor polynomial. All right. Let's take a look at one more here together. Number 8, the last one, number 8. Suppose that g is a function which has the following continuous derivatives. So they're telling me this is my initial g, that's my original value. There's my slope, -2. There's the value of our second derivative and the value of our third derivative. They want to write a Taylor polynomial of degree 3. So they're saying they're giving us n is 3 and centered at 5, so c is 5. So this is really easy to do. AP loves these. So we want to write a third degree Taylor polynomial. And remember my rule. It's this. The nth derivative at the center over n factorial x minus the center to the n. Always write that down. And I can just plug that in. Ready? I want to find the value of my 0th derivative. So if I let n be 0, so if n is 0, it's just 3 over 0 factorial x minus my center is 5 to the 0. Next, minus because my value of my second derivative is negative, minus 2 over, and this just becomes for us what's that? 1 factorial, because now we're at n equals 1, times x minus 5 to the first. And then the next one, let n be 2. That becomes plus 7 over 2 factorial x minus 5 squared, and then minus 3 over 3 factorial x minus 5 cubed. And I can clean this up because the entire first term just becomes 3. So I can write this as 3 minus 2 over 1 factorial x minus 5 to the first, plus 7 over 2 factorial x minus 5 squared, minus 3 over 3 factorial x minus 5 cubed, if you want to clean that up. And then you can just plug that 4.9 in, just like a tangent line, and you would get your approximation for part B. All right, hope you enjoyed these videos. I will see you later. You guys have a great day. Bye-bye.